Welcome to 18.1, Naming Lines and Angles. So we're just going to go over how various parts of geometry are named and the symbols that are used and the vocabulary that's used. So draw a line in number 1. So if you do this, that's not considered a line. A line goes on forever. Clearly that doesn't. So how do you draw something that goes on forever? You put arrows at the end. Now your line could face any which way, but that's the way a line is. So the next thing says draw a line segment. A line segment is part of this line over there, right? And so it has points on the end, and these points on the end are called end points. So the next, number 3 says draw 2 parallel lines. Well, if they're going to be parallel, again, they have to never intersect, right? And it says lines, so you have to draw arrows on the ends. All lines go on forever in geometry. Perpendicular, we talked about that word, and it says line segments, all right? So you could have drawn several different pictures. That's horrible. Let's fix that. All right, so there's a line segment, and another one perpendicular to it must be at 90 degrees. So you say the angle is a right angle, but the 2 line segments are perpendicular. Now, they could also face this way, as long as this angle is 90 degrees, and you have end points on the end. So we're going to learn how to name the angles in there. In that picture, there are 3 angles. There's one right here. There's another one over here. I'm going to put 2 arc marks, it's called. All right, and then there's a big right angle right there. All right, so line. A line is always straight, so we actually don't need to say the word straight. So if you have something that looks like that, that's called a curve. Okay? And they go forever in both directions. So that's line segment is part of that line. It has endpoints. And the third possibility is a ray. The ray has an endpoint on one end and an arrow on the other. So identify the first one. So hopefully you see arrows on the end. Okay, so that's a line. This line has points, CD, on it, but they're not on the end, so they're called plain old points. And you can call this with 2 names. You can call it line CD, so the symbol for a line is a picture of a line, or you can call it line DC. The name of a line does not tell you anything about where those points are or what order they're in. So name this, right? This is a line segment. You can tell because it has endpoints. Name it, please, just like the last one. So this is JW. Now, when you do the symbol for a line segment, you do not put the little points here, right? You just put a plain line segment. And obviously, just like the last one, you can call it WJ. You name it by its endpoints. Now, say I had another point X there. You would still call this JW or WJ. You name these things with the 2 letters. When it's a line, it's any 2 letters. When it's a line segment, it's the 2 letters that are on the end. Third possibility, yes, this is a ray. Now, rays you can only name one way. They're the tricky one. The endpoint letter has to go first. So what would be the correct name of this? This is ray MG because M is the endpoint. G is a regular point. And so now when you do the symbol for a ray, it always points in that direction. It does not tell you what direction a ray points, right? If the ray was going this way, we would not change the symbol to look like that. That symbol is just telling you there is a ray with M as an endpoint and G as another point on the ray. Everything is either a line segment, or array. So there are notes telling you about how to name array. So this is a array, arrow on one end, endpoint on the other. Name it, please. The only name you can call this is ZA. You could not call it AZ. The endpoint has to go first. This actually has 6 possible names. Now that's a line. You always use 2 letters to name a line. So see if you can come up with all 6 names. Pause. So notice, you name a line with any 2 points. Those points can never be on the end because the lines go on forever. You just pick any 2 and you use them to name your line. Now, this says name 3 line segments in the figure. So if you're talking about this part, you would call it line segment DE, or you would call it line segment ED. Find some more. If you're talking about this part, you would call it line segment EF, or you would call it line segment FE. If you want to talk about the whole segment, the name of that is either DF or FD. So there are 3 different line segments there that you can name by their endpoints. Now an angle you typically name with 3 letters. The key to this, though, is the corner, the vertex. The math word for corner is vertex. Letter has to be in the middle. So come up with a name for this first angle. So one name of this is angle KEV. So E is the corner or vertex. So the E has to go in the letter. And this is the symbol for an angle. It does not look like the real angle. So come up with another name. It's also angle VEK. E is in the middle. Now there is one other name you're allowed, but you hardly ever get to use it. And that is just naming it angle E by the vertex. Now that's the easy one. Why don't you use that? You'll see in a second why we hardly get to use the easy one. So come up with 3 names for that. So angle HPL, notice the angle symbol stays the same. Angle LPH and angle P. What do we call the corner? We call it the vertex. The vertex letter must be in the middle. Right, so here's that picture I showed you earlier. There are 3 angles there. You only have to come up with one name for each of them. But there are 3 angles to be named there. Well, this angle right there, we could call angle ABX. We could also call it XBA. B is the vertex. So name another angle. Well, there's one over here, and we could call that one XBC or CBX, either one. And then last, we have this right angle from there to there, and we can call that angle ABC or CBA, as long as the vertex is in the middle. Right, so hopefully this shows you why you couldn't call these angle B. Why couldn't you call them angle B? Because you couldn't tell them apart, right? So yeah, in the simplest picture, when you have an angle hanging out all by itself, you can use one letter, the vertex. But that doesn't happen very often. You're going to use 3 letters to name your angles, 2 letters to name your line segments and arrays. We asked you to do this in the warm-up. Draw two perpendicular line segments. So hopefully you have something that looks like that. Now I want you to draw a circle around the edges of it. Around the edges as best if you can. So I have the advantage of technology, so there's my circle. How many degrees, all right, it says in a circle there are 360 degrees. When you go all the way around, that's 360 degrees. How many degrees in a semicircle? Semi means half. It's a prefix that means half. So how many degrees in half a circle? Well, it's 360 divided by 2. Which is 180 degrees, right? If you're a skateboarder and you turn around, you've done a 180. If you spin all the way around, it's called a 360. How many degrees in 3/4 of a circle? Well, here's 1/4. 1/4 has 90 degrees. So how many in 3/4 of a circle? 3/4 of a circle is 90 times 3, 270 degrees. So we're already at the practice. So I want you to tell me if that's a line segment array, and name it. Hopefully you wrote line segment and gave it either the name BR with this symbol, no dots on the end, no points on the end, or RB. That's array. It only has one possible name, HD. You cannot call it DH. The endpoint H has to go first. So draw an example of that. There's many right answers. Well, that's line ST, so that means I have to draw something with arrows on the end, and you have to put some points on it. I'm going to intentionally put them backwards because the order of the letters is not the order of the lines necessarily, the order of the points on the line. What do we call the corner? I literally just said that. If there's 360 degrees in a whole circle, 1/4, you divide by 4, there are 90 degrees in 1/4 of a circle. Well, I just said it, right? In an entire circle, there are 360 degrees. And each of those has one other way, but y was the vertex of each of those angles. You can't call them angle y's because you couldn't tell them apart.